7 o'clock.
It is 7 o'clock, yes. So for those of you who are here, and if you're not yet a member, just be aware that we're going to use about the first 10 minutes of today's meeting to do our annual board elections, which hopefully won't take long. But we're continuing to let people into the room, and we'll be holding those elections in a short moment. Please.
So if you are not sure whether you are a current member, I'm the current treasurer, so you can ask me and I can tell you. If you, and actually, let me add something here. If you paid by check in 2023, kind of send this account a DM and just letting me know that, because I'm trying to track down a potential oops. And I want to make sure that people who are members are actually counted as being members. So. Yeah. I'm not seeing anything come in, so hopefully that's a good sign.
I sent you a check about a week ago or 10 days ago for a family membership.
Oh, okay. That would not have gotten to me yet due to our convoluted internal SoVerA mail system, but we will take you at your word.
Yes, you can vote tonight, sir. Yes, we'd be happy to have you vote.
Yeah, everything on PayPal, that I got you. I have an updated list on that. So, but so thank you for letting me know that, because I'll just tell you all. So mail goes to SoVerA's PO box in Chester, but I don't live in Chester, and so Rick, who's also a board member, picks up the mail, and then every probably quarterly he sends me a big envelope of everything. So what I call the Rick Express is extremely reliable and cheap, but not very fast. So it usually takes me a little bit to get things that way.
No, let me in.
Oh, yes, we should let
Hooray, you're connected.
the person running the show.
Finally. Had to wait for updates.
Any other questions on membership dues, whether you are or are not? Going once, going twice. Okay. And actually, while I got y'all, it is December, so we have a little bit of feedback.
I was going to mute the audio on that computer when I start anyway.
Okay.
Here, we just need to turn off the speakers. We just need you to.
Oh.
Sorry, I was hearing myself through your computer. So we have a policy that if you pay membership dues or you join for the first time at the end of a year, so for example, right now, or the past month, or even the month before that of 2023, it counts not only for the rest of that year, but also for the upcoming year. So anybody who feels like becoming a member to vote tonight, you would also be getting your 2024 membership kind of wrapped into that. So also anybody who wants to do that, feel free to let me know. Any other questions? Okay, cool.
All right, folks, so we were going to read a little bit about each of the board members who are up for election, or give speeches about ourselves.
I think we can each just walk up and say 2 sentences. That's
Walk
fine.
up and say 2 sentences? Okay. I'd say let's get started because it's 7:04. Pat, can you turn off your...
Yeah, we'll have to...
Okay. I think we're good. Okay. So I'll start. My name's Margot. I've been a member of SoVerA since, I think, 2018, and on the board for just about as long. I am currently the secretary. I love space, and so, you know, if you would like somebody who loves space to be SoVerA's secretary, please vote for me.
Oh, I gotta go.
I'll follow you.
I have to go next. Hello again. I just told you what I do. So, I'm Eric Schmidt. I'm currently serving as treasurer. I've been a member of SoVerA and on the board as long as Margot, because we're kind of a package deal. I taught for 5 years physics and astronomy and astrophysics at a private high school and ran an observatory for 5 years, so I have probably some relevant experience there. But mostly I handle the finances and the paperwork and the IRS filings and all that fun stuff. So. Oh, and while I'm here, oh, thank you, Pat. I already answered. Yes, I think that's all. Pat, you're up. Yep.
We're juggling laptops here, so bear with us. For those of you that don't know me, my name is Pat Porch. I'm currently the president of SoVerA. I joined SoVerA in around 2008, and I think within a month, Claudio had me on the board. You got to watch him; he's good at that. I served on the board off and on throughout the years, various capacities, and this past few years has been challenging, and to be a board member has been very challenging. And now that we're past COVID, we think we're past the bad weather, and we have a place to call home up in Wethersfield where we can gather and observe. And we're feeling re-energized, and we have a lot of good ideas to move forward, and looking forward to everybody's support to make it all happen.
Hello, my name is Kevin Paquette. I'll be your speaker tonight when we're through with the voting. I have been with SoVerA since 2016. I would rank myself as an interested amateur. I don't think I can really lay claim to anything outside of that. And I am currently serving a term I was appointed to as a director with no title. And I like that because that means I don't have any homework to do. I thank you for your support. Oh, and Rick Bates, come on over.
I'm not Rick Bates.
Yeah, Rick Bates he'll be back.
I have a statement from Rick Bates, who is our current vice president. I'm Rick Bates. I am currently the vice president of the SoVerA board. I have been active in SoVerA for the past dozen years and wish to continue to serve as a board member. In my years with SoVerA, I have given presentations to the membership and have been part of teams who have done presentations at schools in southern Vermont and New Hampshire. I'm also active in organizing star parties and other outreach work. My particular interest is in archaeoastronomy. So there you have it. That's the current board. That's the roster that is currently on the table for voting. And should anybody currently in the audience wish to join the board, you may certainly make a statement, and we can vote for you too. So I guess the best way to do this would be if you go to typing a message and there's a blue drop-down menu. When you go to 2, select SoVerA, which is my account, and send me a direct message for your vote.
That's not the one that's logged in on that computer, is it?
It is.
Well, they can see that.
Not if they select, what do you mean they can see it?
When they send things to you, they can see the DMs that you receive, because that screen is connected to Zoom.
Oh, send your votes to Pat then.
Then send the votes to Pat.
Let's just play it safe. Send it to Pat.
Yeah, let's play it safe. Send your votes to Pat. Direct message Pat. So in the blue drop-down menu, you'll see Pat, our current president, and we'll collect your votes that way.
Do you want to open the floor for anybody who's nominated?
Yes, and the floor is currently open
Oh.
for folks to nominate themselves, should you wish to join our.
I got one of them, so.
A vote or a
Yeah, please.
So if anybody who's considering and hesitating joining the board, we would love more of you to join us. In case you're, let me tell you some important things. There's no salary. As treasurer, I can definitely confirm that. But if you're worried about the amount of commitment, just to give you some information, we meet monthly. So it's the second Tuesday? Third Tuesday. Second Tuesday is this meeting. So we meet every third Tuesday at 7 o'clock, and we're generally done by 8:15 is a longer meeting. Sometimes we're done even
We meet
quicker.
by Zoom, so
And
it's very flexible.
And we meet by Zoom. You don't have to drive anywhere. You can sit on your couch. And while there's a little bit of outside of meeting work to do, it's mostly unless you're an officer, So unless you are the president kind of doing the heavy lifting, or the secretary doing lots of paperwork, or the treasurer doing lots of paperwork, there's not a lot of homework. It's mostly the outside of meeting work for the board members is mostly arranging speakers and trying to network to get speakers in, and doing whatever outreach you can. But the expectations are fairly low. So if you're hesitating due to, I don't know if I have time, I just want to say it's about an hour to an hour and a half's work per month if you're a board member at large without any additional responsibilities. And if anybody has any questions more about that, if you're considering it, feel free to speak up loud. I'll be happy to answer. Otherwise, we'll keep on voting.
Okay,
How long do we wait?
let's, we're at 7:11, so,
7:15?
yeah, at 7:15, we'll get a show on the road with Kevin's Venus talk. Let's keep it moving, folks.
Yep.
Yes.
Do we vote?
Yes. Well,
Sure. You're allowed.
Okay.
I paid my dues.
I guess we can vote verbally at the end,
Yes.
so as not to startle anyone.
Vote against yourself, Margot.
You know, I'd love to, but nobody else wants to be secretary, so.
I feel your pain.
I know you do.
Well, also, Rick is not here to school us.
Oh, thank you.
So Rick is not here to school us, but I believe, so you guys are voting for us as board members, but then the board kind of arranges ourselves into officers. So the only way to free Margot from secretarial duties is to boot her off the board. So anybody wants to change their vote?
Welcome, welcome. We've got some in-person folks coming in too.
That was self-serving. She said earlier we were a package.
Right, yes, yeah, you said we were a package deal. So, you want to get booted off the board too?
If anybody wants to be treasurer, let me know. Right, so we're doing some voting for the board.
Oh, okay.
So,
We'll just abstain, we'll sit here and be quiet.
okay. However, you apparently don't need to be a member to be nominated to the board. So if you'd like to nominate yourselves to join the board. Okay, thank you, Mr. Chair.
Just counting how many we got. 1, 2, 3, 4, 5.
This one will take a second. Thank you for coming. I'll be the one speaking. We just got to get to our annual election first.
I think
The high conclave of the stargazers.
I think we're at a unanimous.
Yeah, we'll something up, tightening up to do there anyhow, so.
Okay, one more minute, folks, to get your votes in,
Yeah.
or forever hold your peace, or rather for a year, hold your peace
Hold your peace for next fiscal year.
for the next fiscal year, yes.
Margaret,
What's that?
while you were here, Margaret, while you were here, I just managed to get lost in every technical issues that they say.
If you want to vote, yeah, so send your vote to Pat. So Pat, Eric, myself, Kevin, and Rick, we all did introductions and we're kind of like presented ourselves as a package for folks to vote to keep the board, and also for folks on the board to nominate themselves or others to be on the board. But if you're in agreement with keeping folks on the board, send a vote to Pat. Or if not, you can also send it. I did not mean to skew things that way.
Yeah, I think you just rigged the vote.
I did just rig the vote. No, I've done
So
it.
you do want to stay secretary?
In one of the next directions, I vote to maintain the status quo.
Okay, sounds good. All right. So we're at 7:15, which we had arbitrarily decided would be our cutoff. I think we've received all votes. So I'm going to pass it off to Kevin, who is our speaker tonight.
Is that everything?
Or am I passing it off to Pat?
Are we done with voting, or?
We're done with voting.
Okay.
Yes.
We need to vote.
All
not me.
votes.
Oh,
are-
we need to vote. I get a vote too. Okay.
Yes.
All votes are in favor to keep the board as is.
All right.
Okay, all votes are in favor to keep the board as is. Board members,
But look at that. Even if we didn't want to, we couldn't
Aye.
outvote them. There's too many of them.
that's true, we can't outvote you guys. So you've outvoted the board, we're stuck with you all, you're stuck with us for another fiscal year. So thank you for your support, and here is Kevin Paquette.
Give me just a minute to get situated. I'm going to mute the computer audio, but at the end of the talk, there'll be a window for questions. So if you have any, you can ask them then. I just don't want to give you feedback. There, okay. And now I open my Chrome tab. I haven't done this since we used to meet in person, all those long years ago. All right. So, my name is Kevin Paquette. As I told you during the election, I've been a member of SoVerA since 2016, and in 2017, I gave a talk to a total of 7 people, all of whom agreed to meet to hear from me in the basement of the Chester Town Library about Venus. And the title was Venus, the Worst Planet. And a lot has happened since then. A lot. God, so much has happened since 2017. But I'm here, and you're here. And this is the first cup I have, and it's enormous, so just... Good stuff. All right, so, if you're like me, you're alive. And if you're like me, you might have wondered how you got that way. Life begets life. We don't have an easy answer for where life comes from in the first place. We have a whole bunch of theories. There's so many theories. But right now, we don't know for sure. And that philosophical problem, I guess is how I'll categorize it. I could go in a lot of directions there. That philosophical problem is one of the points I'll make tonight. Because these are the terrestrial planets. We have Mercury there on the left, then Venus, and then Earth, then Mars. Their actual size, most people don't know that. Mars is really just two. Oh, hold on. You don't see the PowerPoint? Also, I thought I muted this, and apparently that didn't work. It says it's muted. What is going on?
You shouldn't be able to talk.
Can you not see the PowerPoint online? I have it full screen.
No, that's not.
Oh, you have to share your screen in Zoom.
I didn't. I thought you set it up for me.
Oh, no, I did not do that.
You know how to do it?
No.
Oh.
I say that was a host.
Yeah. Can you figure out how to mute the computer too?
You know, use the microphone.
Yeah, you shouldn't be able to hear them, but it'll be okay.
All right. I will respectfully ask you all to hold your questions till the end, just so I can stay on track.
Pat, are we good on the share?
Yeah.
Okay.
All right, everyone can see everything. I can full screen. Okay. I know how to do that.
Okay.
All right. So slideshow.
Beautiful.
How do I make this go away? Is there really no way to get this overlay to disappear?
They can't see it, only you can.
Okay, well that's what matters. So here, tonight's talk is Venus, the hothouse tech next door. I am Kevin, and here is SoVerA. So, as I was saying, these are the terrestrial
Are we
planets.
recording?
And I just realized that joke I made a minute ago doesn't make any sense. These are the real relative sizes. On maps, the terrestrial planets are often shown as being the same size, and they're not. Mercury and Mars in particular are much smaller than Earth. Venus is close to the same size as Earth, but not exactly. Gravity on the surface is 93% roughly what we have here. And the bulk composition, which is the fun way of saying the ingredients, is about the same. Everything else is wildly different. Venus is the second rock from the sun. It gets more sunlight. The sunlight has done terrible things to Venus. And what we see there is heat. Just so very, very much heat. The atmosphere is almost entirely carbon dioxide, and the pressure on the surface is roughly equivalent to being 2 miles underwater. It's really, really very bad. However, Venus is still more Earth-like than most other planets. It's debatably even more Earth-like than Mars. Venus has a substantial atmosphere. Mars has a tenuous atmosphere. Mercury has almost no atmosphere at all. It has a hard surface you, in theory, could walk around on. And it has what are considered to be the 6 key elements for life. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. In particular, it has sulfur. It has so much sulfur. And we will get to all of that in a moment, but I would like to start at the very beginning, because the beginning is a very good place to start. This is what we know now. Venus is Earth-like, emphasis on like. A lot of the numbers look about the same, which is fun. The surface conditions are radically different. However, that is a relatively recent understanding. I don't know if they still publish them, but there used to be books you could buy that were just, I think they were star charts. It was like what you would see in each corner of the sky every day of the year, and you buy a new one each year. You could do it with Stellarium now, but they're fun to leaf through. And I remember one of those had relative angular sizes of the different planets you could see through a telescope. And Venus roughly ties with Jupiter for angular size, with the caveat, of course, that they both move around a lot relative to Earth, and so they gain and shrink. Venus is much, much closer than Jupiter, even though it's much, much smaller. And it is covered in clouds. And for a very long time, all we knew was that Venus was close to Earth and it was covered with clouds. And so that is where we will start. In the beginning, we are an astronomy organization. So I'm going to belabor the point a little bit and show you Venus as you would see it through a telescope. This is an amateur telescope photograph somebody kindly furnished to Wikipedia, which I downloaded for this purpose. As you can see, Venus is a crescent, and we'll get to that in a moment, but also it's basically a fuzzy, featureless white sphere. And if you look at pretty much any of the other planets, you'll see more than that. And that's the paradox of Venus, is that it is so close to us and yet so opaque. This is Venus as you would see it with the naked eye at night. It's an unusually bright dot. And that's it. Planets, most of you know this, but for those who don't, planets are called that because it stems from the Greek word for wandering. They were thought of as wandering stars. And Venus is the brightest of them. Venus is the 3rd brightest object in the sky on Earth after the moon and the sun. I should say the sun and the moon. Venus is what's called an interior or inferior planet. In this context, the two words mean the same thing. It is closer to the sun than Earth is. And because of that, you see, what's the word I'm looking for? Phases, like you do with the moon. Now, Venus can be fully exposed, like a full moon, but when it does so, it's behind the sun. And of course, when it's quote-unquote new, you don't see it at all. So if you see Venus from Earth, it's always going to be the crescent. That's not obvious if you're just looking at the dot in the sky, but it's easy to pick out with a telescope. And the best times of year to see Venus are, well, it moves around as Venus moves around, but within its cycle, the best is when it's roughly halfway between new and full, the point of maximum elongation. It stays in the sky longest then, and you can see half of it. And that is about as good as it gets. Incidentally, You may have noticed the caption to this illustration from 1857 refers to Venus as she. Venus is named after the Roman god of love and beauty, also known as Aphrodite to the Greeks. It is the only planet, major planet I should say, that is named after a female deity rather than a male one. And so now we enter the early modern era with telescopes and the transits of Venus. I think many of you may remember this. The last one was not that long ago. I hope you all enjoyed it. For me, it was cloudy that day. We're not going to get another one in our lifetime. According to Wikipedia, the transit of Venus is among the rarest predictable astronomical phenomena. The planets all orbit the sun in a plane called the ecliptic, which is a really fun word to say out loud. It's a disk, sort of. The planets are not completely flat within it. And so Venus only lines up with the Earth and the Sun briefly and on rare occasions. And it's a big deal when it does. I guess some of you might still be alive in 2117. I'm not banking on you being there. But that's okay, because we got lots of good pictures from the last one. And now we'll talk about Venus in fiction. This is important to me. It's not strictly astronomical, but it's fascinating to me. Let's see the telescope age here. Because Venus was a mystery, and because there were a lot of now disproven scientific hypotheses about the solar system and how it formed, it was imagined that the outer planets were younger than the inner planets. Older rather, I'm sorry, as though the solar system was formed from the outside in. That's not the current theory, but it was at one point. And science fiction writers used that as liberty to imagine Venus as a Cretaceous swamp, among many other things, but that was the theme they kept returning to. Venus was going to be hot, and there had to be water there, because look at all those clouds. And why not just stick some dinosaurs in there for fun? So if you're reading stories about Venus from, I'll say, 1900 up to mid-1960s, they could be anything. It was really wild. They were all completely wrong. We'll get to that. But I love the variety that this brought out in the human mind. So as science fiction advanced alongside science, Venus in the popular imagination became a swamp world. Looking at the frozen desert of Mars and the vibrant life of Earth, it was conjectured that Venus would be something like Earth as it had been in the past. And that may actually be true, just not in the way they interpreted it. There's a transitional period between this and the space probe era, which was, I don't have any good pictures of it, but I'll mention it because it fascinates me. It is possible to bounce radar signals off Venus from Earth. The resolution you get back is not good, but it was good enough that they could sort of see some features. And so there are 3 features on Venus that are not named in accordance with the scheme that everything else is named. Most things on Venus are named after various female deities in different religions. But there is Alpha Regio, Beta Regio. Am I pronouncing Regio right, or is it Radio? Yeah. And well, that's not Pluto. There's one more, Maxwell Montes, named after a scientist, just because nothing can ever be completely ordered. And so, as we leave the primordial, what is down there, imagination era, and enter the science era, there were a lot of competing visions. And I spent a lot of time looking at these old magazine covers, wondering if the science fiction writers ever actually believed that stuff or not, because if they did, good for them. And now we have arrived at the age of hard science. This is Mariner 2. Mariner 2 was the first spacecraft to return data from Venus. I phrase it like that because the Soviet Union, which as some of you may remember, was engaged in a very heated game of rock, paper, scissors with the United States to own space. I'm contracting a little bit. There were some fine details from that. But basically, they sent out a probe called Venera 1 Venera just means Venus in Russian, but I'll call it Venera because that's how it's been put down in English language literature. And Venera 1 made it all the way out of space and just died. And it went past Venus, and we don't know what it saw. It's still out there somewhere. And that's true for most of the spacecraft I'm going to show you today. We flip ahead to my timeline of spacecraft. I want to talk about the Mariner program for a moment. Now that's back to Venera. The Mariner program is unintentionally hilarious to me because they had this idea that, oh my God, there's so much space and we finally figured out rockets. Let's do everything. And so they built these really simple, comparatively cheap space probes. They didn't have a lot of instrumentation and had fairly low ambitions, and just drop-kicked them into space. They went like nuts. Mariner 2 is the first one to Venus because Mariner 1 was destroyed by ground guidance control after the rocket went off course. Mariner 1 is in pieces in the Atlantic Ocean. Mariner 3 was supposed to go to Mars. It suffered the same fate as Venera 1. It made it out into space and perished. So Mariner 4 was the first probe to Mars. Mariner 5 went back to Venus. I think the next two went to Mars. And at that point, it had been determined that Venus was not a great place and Mars was looking a little better every day. And that's a theme that's going to end up defining the rest of this lecture. What we look for in space can become a self-fulfilling prophecy, because although we look at it through the lens of science, there's also this very human idea of what is in it for us. And that might not be what the scientists are thinking about, but that's what the public is thinking about, at least some of the time. So I think that is the core of the quest to find life, which is another thing we're going to come back to, because if a planet can have life, then maybe we could go there someday and live there. Truthfully, you've probably already been to the best planet. The others are really just, they don't compare. But that doesn't mean people won't try if they ever get the chance. Back to the Venera program. So the Soviets, after flying past Venus, decided they wanted to go down to Venus and have a look at it with, computers. Now, this is Venera 4. Venera 4 entered the atmosphere of Venus and got part of the way down and broke. And, oh no, that's the best part, I'm saving that for a minute. They built a string of these. Each one was more temperature and pressure hardened than the last. And by the time they finally got one to the surface and discovered that it was good, which I think is Venera 7, which we'll get to in a moment, they realized that the surface of Venus was an absolute baking hellscape, which was not at all what had been predicted, even in scientific literature. It was, I'm sure there were probably some people who got it right, but the main road concept, middle of the road, was that Venus would be hot, but the clouds would compensate for that a bit, and it would all sort of be okay. It was not okay, but it took them a moment to realize that. So between when I gave the talk in 2017 and when I was getting ready for this, when I came into possession of a box of newspapers, which contained about 200 issues of the Valley News, and you better believe I looked over every single one. This was a United Press International article that was published the day after Venera 4, which in this literature is translated as Venus 4, successfully entered the Venusian atmosphere. And allegedly, someone up in the Soviet command, who was not named because they were afraid the Americans would assassinate their brightest minds, said, oh, we're going to put cosmonauts on Venus by 1980. And if you read further into it, apparently people further down the channel are like, maybe it'll take until 2007. And at the very, very end, I'll just read this, I think it's hilarious. Venus 4 confirmed what scientists already suspected, that Venus is too hot and lacks the chemical structure to support a life similar to Earth's. But biologists said it well could support a primeval type of life, which as might have existed on Earth eons ago. And we will get back to that too. Venera 7. This is the one that made it all the way down. It's still down there. I imagine the warranty has been voided by now. And at the end of the Mariner program, after going to Venus and Mars a whole bunch of times, they sent a probe to Mercury. That was Mariner 10. And on the way there, it took this picture of Venus. This is not a particularly impressive picture of Venus, but it is the only one I could find of Venus in color, in natural light. And I want you all to look at it. People looked at this as a fingernail in telescopes for hundreds of years and had no idea what they were looking at. I read a whole book about the history of the exploration of Venus, which has a bunch of fiction in it, so it's hilarious. It's called Farewell, Fantastic Venus. And if you can find a copy of it, it's out of print, but it's very fun. They did studies where they just put like a billiard ball and lit it from one side to the far end of a room and had people sketch what they saw. Because they were worried that maybe Venus was completely featureless and everything they thought they were seeing, there had been a lot of proposals along the way, were either optical artifacts or stuff on the inside of the observer's own eyeball. Apparently, if you stare at a bright light long enough, you'll see the veins in your, well, the capillaries in the back of your eye. I love this giant cup. All right, there it is. You all looked at it. Not much, but stay with me. If UV, it gets better. The clouds have texture, and for the first time you can see something that we now believe is a defining feature of the Venusian atmosphere. There is circulation that rises at the equator and descends at the pole. That sideways V shape you see in the clouds is the circulation going all the way around and being wrapped as it goes because the length of travel changes. This, I might hang myself with improper terminology here, but this might be the Venusian version of the Coriolis effect. I do know the circulation cells are completely different on Venus than they are here, but I'm not an atmospheric expert, and I don't want to wade too deep into that. After the Mariner era was over, the United States sent Pioneer Venus over, which was fun. This is an oil painting. I love that NASA used to have people just do concept oil paintings. They need to bring that back. Of the orbiter and the probes it dropped. One of the probes made it all the way down to the surface, even though it wasn't designed to, and reported there for over an hour, or so I read. Not that I talked to the probe myself. That was in 1978 when I believe it was launched. Magellan was the last, I would get sad when I talk about Magellan. Magellan was the last spacecraft to be, it was a junk drawer spacecraft made out of parts that had been left over for other missions. I forget exactly which piece came from what, but the dish was a spare from one program, and the bus was a spare for something else, and they cobbled it together. And there are a few custom bits of kit on there, but mostly it was leftovers. And it was supposed to go up on the Challenger, and that didn't happen because the Challenger had been. And so instead, it was launched 4 years behind schedule and did survey work in radar on Venus in the early 1990s. And this is what that looks like. So if you're wondering exactly what it means to radar map the surface of a planet, this is that. The probe goes around and around, and it beams down radar signals, and it studies the reflection pattern that it gets from the surface in stripes. And with the stripes stacked together, eventually it can build a complete map of the surface. You'll notice the probe is angled relative to the true position down. And that's so that they can go around twice and get the height angles by pitching it in two different directions. Sort of like how a phonograph needle reads a stereo record, which has different patterns on either side of the groove, which I think is cool. And this kills me. This is it. This is where Venus stops for NASA. In 1994, Mariner, with help from the Pioneer Venus orbiter, which somehow was still working after 12 years and was reactivated to assist it, the two of them went around and completed mapping. And this is what they got. It's not 100% of a mosaic, but it's quite good. And After that, Mariner ran out of, not Mariner, I'm sorry, Magellan, thanks. Magellan ran out of propellant for attitude control and was allowed to decay down to the atmosphere. All these pictures, I've never completely understood why NASA did this, show the surface with, this would have been a black and white image, but they show it tinted orange and then the sky is black. The sky on Venus is probably actually yellow when we get to that bit, and the ground is just rocks. But I think they just wanted Venus to have its own color scheme and they succeeded. You'll notice on the 3D model, there are spots that are white. Those are points of high reflectivity, and to some extent they reflect altitude. There is something on Venus that is provisionally referred to as the Venus snow. Oh, can they see that? Oh, okay, it was a pop-up on the computer. I don't know, I'm behind the times. Standing here talking about a space probe from 1984. Where was I? Ah, yes, it's snow. They don't 100% know what that is yet. The belief is that it is metallic sulfides that have been deposited. It's not water ice snow. It is far, far too hot there for that. But that's just what it's called. That's what it looks like on the radar maps. The hope is that future missions, can I get the taskbar to go away? Oh, Windows 11, why must you be like this? The future missions will tell us more. This is a concept graphic. It isn't super scientific, but I just really like this. NASA was online from the very beginning, and the NASA web page from 1994 that explained the Mariner mission is still up in an archived state. And this is an image from it, and I just find it charming. I appreciate that someone went to the trouble to make that. Sees the atmosphere, but of course the atmosphere kicks back. One of the last things Magellan did on his way just before full deorbit was a thing called the windmill experiment, where they tested how much air resistance there was by allowing the outer edge of the atmosphere descending low enough to turn the solar panels like the blades of a fan. And by measuring the resistance they got from that, they learned things. Learning stuff with the tools you have is a really good skill to have. It's great to have good tools. It's better to have a good mind. And things like this, where you just study how much turbulence fights your spacecraft as it's dying, that's a good use of taxpayer dollars, in my opinion. So this is a convenient graphic I wish I had 6 years ago, because it recapitulates everything I've already said. There is the ecliptic, it is horizontal in this picture, and those are the orbits, or in the case of Venera 4, the final approach, of most of the spacecraft that I talked about. Mariner 2 just zipped by, the others did orbits, and then of course the one went down to the surface. Just for context, and that is the sun over there in the corner of that hemisphere. And this, after everything else, is a color-coordinated altitude map. You know, I really should have gotten one that had labels on it. I'm sorry. But the red and white points are mountains, and the purple and blue areas are lowlands. Notice, I'm guessing many people here have seen surface maps of Mars. Mars, if you call it up in your memory, is very much defined by craters. Venus has craters, but not many. The thick atmosphere tends to eat up anything that's coming down from above. So the surface on Venus is heavily defined by volcanism. There is the possibility that there were plate tectonics in the past. I think I have a slide about that later. But mostly they think that it's just something like on the order of 90% igneous rock, specifically basalt. It was the next slide. I should have had more faith in myself. It's believed on Venus that because it is so very, very hot, that it hasn't cooled to the extent Earth has. And the crust is both thinner and, they put the word plastic in quotation marks, but that's the original sense of the word, flexible, as opposed to Earth, where the crust is rigid. An open question is how much water, if any, is locked up in those rocks. 6 years ago, I had a phone call that I was able to record and take notes on with a woman named Suzanne Smirkard, who is with NASA. She was with them then. She's now in charge of one of the missions I'll tell you about later. And I'm very happy for her that she and the other Venus scientists were sort of out in the wilderness for a number of years because there were no missions going there. And one of the questions they wanted to answer, that finally might be able to, is how much water there is, because the amount of water in a planetary crust affects how much the surface can move around relative to itself. So on Earth, there are plates, they subduct, mountain ranges are formed. On Venus, they think it might all just be one surface with hot spots, but they don't know for sure. And for whatever we see now, it's possible it's different in the past. Breathing. After all that, this, I've held off on showing it to you, this is the surface of Venus. There are no dinosaurs, there are no plants, there's no water, there are just rocks. It's not super obvious here, but this was taken, I will try to show the camera here, I don't know where the frame is, so forgive me if it gets cut off. It's a sweep like this, so that white spot on the right is the horizon, and then the camera pans down to the rock field directly in front of it. And most of the surface of Venus looks like this, as far as we can tell. Just shattered rock. There's a lot going on at Venus, but there's not much going on at the surface, and that was the heartbreak, was that Venus could have been anything, and it was this. But wait. Now, when we talk about spacecraft, it has to be weighed. This might sound absurd to a scientific crowd, but it is very much in the minds of people at NASA. They want to be able to pitch missions that seem like good investments. They want safe missions that return lots of data. Venus, if you really want to go down into Venus, does not offer that. What is this thing here in the corner? Can you see that? All right. Sorry, I kind of zoomed problems on mine. So on Mars, you can send a rover down, and if you get through the tricks of making it to the surface in one piece, you're golden. You can go for years. It's sort of forgotten now, but the planned lifespans of all the rovers they sent to Mars were measured in Earth days. We've had really good luck. Opportunity, the batteries finally ran down because the solar panels were choked up with dust for too long. That was a shame. The two newer rovers we've sent there are run by radioisotope thermal generators, and they will run until the plutonium is done falling apart. But on Venus, you can't do any of that fun stuff. The survivability problem is key. The lifespans for missions to Venus, on the surface that is, even now are measured in hours. I sat in on the latest annual meeting of VEXAD, Venus Exploration Advisory Group, and they're still talking about missions in hours. And scientists don't mind missions in hours. You can get a lot done if you plan it ahead of time. The public is not super enthusiastic about them. However, Venus does have a hard surface. You can go down there and look around, and if you really want to be fanciful, you can still imagine people in diving suits walking around there with a whole bunch of armor and a whole bunch of insulation. But also, there's just this profound letdown, which is the third point, the weight of expectation. We thought Venus was going to be so many things, and it was none of them. And so for, 30 years, NASA just walked away. And they had other things to do with. They got a lot of good work done elsewhere, but Venus was sort of forgotten even though it's so close. And there's still a lot to be studied. These are the landing sites for the Venera probes. Notice they have a shotgun cluster. The missions that have gone to Mars are much more spread out. Vega 1 and Vega 2 were balloon insertions from the Soviet Union. The Soviets sent out the Vega probes to look at Halley's Comet, and they sort of had these things that just dropped off at Venus on the way to the comet. And they had balloons that did atmospheric sampling for a few hours until the batteries ran down. was a really cool idea that they proved could work, but there was no longevity built into it. However, they did give us this, a color photo of Venus. And I know this isn't great, so I'll just skip to the next slide, but I wanted you to see it like this first. Remember how I said that the camera sweep was in part? If you correct for that, this is what you see. So the top is what the probe actually saw, and the bottom is what it looks like color corrected. That stick on the right is a little fold-out armature with a bunch of paint swatches on it. I have read, I think in, oh God, it's called something fantastical, like On Alien Winds, but it was a whole book about the atmospheres of other planets. That when they were sending these missions out, they had some special high-temperature paint they made up, and then somebody discovered they could save some money by not using that. They used normal paint, which did not do well in the Venusian atmosphere, but it was a cost savings of, I don't know, some Copex of the Soviet government. And that's the bureaucracy in a nutshell, as far as I'm concerned. So corrected, the bottom image is what you would see if you had this going on Earth, but above this sort of low-pressure sodium yellow look is what, in theory, the human eye would see on the Venusian surface, assuming a human being could survive there. Whenever people talk about Venus in the popular literature, it is always mentioned in the first two paragraphs that the surface is so hot that lead can melt there, and this is true. But it sort of does Venus a disservice to stop there. The melting point of lead is not that high. These are all the other elements that are solid at standard temperature and pressure on Earth that would be liquid. Well, I don't know what the pressure would, but at the temperatures on the surface of Venus. If you didn't catch it in the card earlier, the temperature on the surface of Venus is about 900 degrees Fahrenheit. And that's the same everywhere. The atmosphere is so thick and so opaque that total convection has taken hold, and it is believed that the temperatures are almost exactly the same at the equator as they are at the poles. The only difference is in height. The higher up you get on the mountains, bearable is the wrong word for it, but it's less awful. At the top of the highest mountain, the temperature is only something like 750 degrees Fahrenheit, which, you know, just dressed well. Let's talk more about the atmosphere, because the atmosphere ends up being the interesting part. Venus doesn't have a magnetic field, or more to the point, it does, but it's induced by the pressures pushed onto it by the sun. And because of that, Venus is experiencing what they call atmospheric erosion. When they talk about how Mars used to probably have water, if they don't say it outright, what they mean is that they think Mars used to have more atmosphere that would allow liquid water to exist on the surface without either freezing or boiling away. Venus has a lot of atmosphere, and because of that, the erosion is taking longer to sweep it out. So that's the image on the left. Let's see if I can do the picture of the bigger, complex detail that I find interesting. The standard ratio of, I want to say it's deuterium to standard hydrogen, so that is hydrogen with one neutron versus hydrogen that's just a proton and an electron, is fixed in, I think, I'll just loose hydrogen around the, that's what I'm looking for, in space. The ratio, and that might not be right, but anyway, the ratio on Venus for heavy hydrogen to light hydrogen is much lower than it is on Earth. And what they think that means is that most of the light hydrogen was swept away by this pressure, and that once upon a time Venus probably had a lot of water, and we just got here too late. These two pictures here on the right, the top one is from, I think, the Venus Express, which is an ESA probe. And then the one on the right is from Akatsuki, which is managed by the Japanese Space Administration. And you can see there's a lot going on in those clouds. That sort of bright spot up at the top is actual sunlight that's blowing out the center. But if you look at the dark side of the planet, you can see all sorts of variation in heat. And that's interesting. for a lot of reasons. This is what we think the atmosphere is like. It is very hot and stagnant on the surface. As you rise up, there are not one, not two, but 3 layers of sulfuric acid clouds. And it's almost pure sulfuric acid. It's not mixed with water. It's really the worst you could be. And that is kind of amazing to me. Things turned out this exquisitely terrible for anything that looks like Earth life. So you have a series of transitional layers, and then the high haze, and then the ionosphere way, way, way up. Note the bars on the side, because most of my personal fascination with Venus came out when I noticed this. One of the best kept secrets in planetary science is that on Venus, you can just about, not quite, but just about get Earth temperature and pressure. You just have to do it 50 kilometers above the surface in the acid clouds. The temperature there at 1 atmospheric pressure is something like 100 degrees Fahrenheit, which is survivable. It's not fun, and you probably wouldn't be able to see a whole lot because you have clouds above you. But you could theoretically, in a Zeppelin or something of that kind, step out onto the deck in a wetsuit and just have a look around, with bottled oxygen to yourself. And you wouldn't need any of these super complex stuff we needed to go into the hard vacuum of space, like the moon, or what we're planning from Mars. There is pressure, so you don't need to stop all the blood vessels from bursting. And the temperature is survivable. Survivable is not the same thing as fun, just so we're clear on that point. This ended up not going anywhere, but I have to talk about it. It might be my favorite space mission that never happened. The Apollo program was incredibly expensive, and it took a very long time. And once the program was mature, it was understood that NASA would not be allowed to keep this funding level forever. And before the project was wound down and all the supply chains were turned off, they wanted to see if they could, get anything else out of the technologies that they had researched and the parts that they had designed. The only thing that ended up coming out of the Apollo applications program was Skylab. But this would have been a crewed flight to Venus from Earth. They would not have landed there. They wouldn't have even stopped. But they would have taken a long curving arc down below the orbit of the Earth, past Venus, and I assume just, taking pictures out the window, and then caught back up with Earth on the upper part of the trajectory. If you imagine the gravity well of the sun, you go down, then you get that energy back as you go out. I really wish they had done this. It would not have been a good use of time or material, but just I don't know, it's just wild. By the late 70s, they weren't really swinging this big anymore. And the only thing that came out of this idea was the idea that you could use an empty booster stage once you've burned up all the liquid fuel in it, and just use that as crew living quarters. The idea was that the floor panels would have holes in them so stuff would flow through. When it was all emptied out, you would just go in there, and it would be like an Airstream trailer. Probably grossly oversimplifying it. And so that was the end of what I think of as the classic space probe era. After Magellan, there was that long gap, and not much happened at NASA. There were other missions, and I'll get to those in a moment. So the talk I gave in 2017 wrapped up about here. Venus was on the outs. There had just been a round of funding for proposed missions. So the way it works at NASA, at least in the current age, is that if you are a qualified scientist and you know all the right people, you make a pitch, which is just like, hi, I would like to, I don't know, I have no idea what the budgets are, but I would like X amount of dollars to build this thing, and then the amount of money it would take to just keep a ground crew paid to monitor it as it goes off and it does its business around the solar system. These missions can last for decades. They're still doing active science with the Voyager probes because somehow isotope generators on those haven't burned out yet, but there's incredible amount. But on Venus, it's usually a lot faster than that, which is part of why it's not seen as a great investment. So anyway, all the Venus projects from that most recent round of funding had fallen through, and everybody was super crestfallen. And that was what made me think, oh, this would be a fun thing to drum up interest for. And then 7 people came, and now I'm doing it here, and there's 5 people here, but there are people on Zoom, so it's all good. I'm making headway. This, I should explain what this picture is. This is a concept image from Wikipedia about what Venus would look like if it was terraformed. Terraforming is so far into the realm of speculation that I'm not really going to talk about it, but I just wanted to show this to you because this is what Venus with the current terrain would look like with water and plant life. I don't think that particular pattern of equator to pole cloud distribution would work out the same with an atmosphere that humans could stand, but I'll let them have it, it's nice. Venus might once have looked something like this, maybe. So here are comparisons of the atmospheres of Earth and Venus. The idea is that in Earth, the higher you go, the temperature gets colder, but that's only true to a point. It actually zigzags back and forth as the pressure continues to drop. At Venus, the gradient over the equivalent distance is much straighter, but you have all these cloud layers to go through. And this is maybe a better illustration to show exactly where the slide rule line would end up for, okay, could I go outside and not die? The magic number seems to be somewhere between 50 and 60 kilometers above the surface, because the temperature then becomes bearable. And then the higher you go, the colder it gets and the thinner the atmosphere gets, and eventually you get a pressure suit again. This is one of the many NASA missions to Venus that never came to be. This was another wild swing, and I don't think this was ever going to happen. This was HABIT, the high altitude Venus operational concept. All the Venus missions have V's in them. They actually complained about that at the FECSAG meeting. Like, it's been overdone to death. The missions I tell you about later, they have V's in them. They get the acronym, you build it around the V. HABIT was going to be basically something out of one of those science fiction novels. They were going to go to Venus and then land in the atmosphere, deploy there, do science with the dirigibles that have solar panels on the top, and then take off there. At this height above it doesn't say exactly where this is, but above the top cloud layer, this is too high up. It could just go outside without special protection. But otherwise, it's quite accurate. What I've read is that the atmosphere of Venus would actually give you a blue sky if you got up high enough, which is another one of those things that's really remarkable to me. Because the atmosphere keeps going after that, and it slowly tapers off more and more and more. One of the earlier slides, if you didn't catch it, said that the upper edge of the ionosphere was something like 1,000 kilometers out. On Earth, the traditionally accepted boundary for the edge of space is 100 kilometers. And now we have to talk about phosphine, and I need to look at my notes to make sure I get all the details right. You probably heard about this. A couple of years ago, there was a study that made everybody sit up and go, wait, what? Because what they had found was phosphine, a chemical I guarantee none of you had heard about before then, that on Earth it's a biosignature. And they had found it in the clouds of Venus. And this is some of the data from that. I have to stress that this data has been challenged since then, and then counter-challenged by the original researchers. And they'll probably fight over it for another decade, because that's how science is done. But what this did to the popular imagination was turn Venus from this autoclave hell world into a place where maybe life could kind of exist. You have a, what do they call it, a hydrological cycle of sorts in the clouds. The acid rain there does precipitate out, and then it hits the critical temperature where it turns back into sulfuric acid steam. And I can't imagine a substance I would less like to be in a room with. And turns back into clouds at the top and cycles endlessly as the sun dumps more and more energy into the Venusian clouds. So there is energy there, And there might be the ingredients for life, maybe, but the kicker is that it is so completely acidic that it cannot be water-based. The atmosphere of Venus, even at the high altitudes, has less water in the air than the air above the Sahara does. I talked about these elements earlier. These are the core elements for life, as it has been explained to me. I am not a biologist, and I don't want to misrepresent myself as understanding more than I do. But carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur are present in all forms of life that we know about right now. And, how to put it, it looks like all that stuff might be available on Venus, fingers crossed. So the molecular formula for sulfuric acid is H2SO4, if I have that right, and that gives you 3 of them. There is a nitrogen gas layer, maybe. So I want to go back to this and show you something. This is a spectroscopy line, I'm pretty sure. So they think that means there's phosphine, they think phosphine means life. But the atmosphere of Venus is a mix. And they have to make educated guesses based on very choppy waveforms about what the constituent components are. If they actually went down into the atmosphere, they could do more sampling. But there is believed to be some nitrogen in the atmosphere very high. And so that's there. The hydrogen, oxygen, carbon from the carbon dioxide, sulfur from the acid, and phosphorus would come from volcanic eruptions. So Venus, when they sent stuff to look at the surface, they understood, okay, this is volcanic, that's what this is. But for a very long time, until like, I think a year ago maybe, they had not actually caught a volcano in the process of erupting. I think they figured out that it had because the atmospheric composition changed slightly. And it is possible that what they're reading is that phosphine signature is actually phosphorus from volcanic eruptions and there's no life there at all. Life is always the outside bet. I have to stress that. I'm going to talk about a lot of fun maybes, but we haven't found life yet anywhere but here. And on that note, I just want to mention this because people talk about finding life in space so much. And we have, well, I have to phrase this carefully. NASA has a game plan for if they find life. The rest of us don't. That life might be extremely dangerous to us. We might be extremely dangerous to it. If we're extremely lucky, our biologies are so completely incompatible that they just sort of bounce off each other. But even the implication of finding life elsewhere would be huge. There is, and this is a real outside possibility, the possibility that life was in microbial form, passed back and forth between the planets by meteor impacts that hit with enough force that they kicked up rocks from the surface of the receiving planet that later landed on other planets. So when they say Mars might have had water and therefore life, and Venus might have had water and therefore life, they could have just been trading. The sun used to be not as strong as it is now. The sun will eventually get even bigger and even hotter. We're about halfway through its lifespan, and I think that's still the understanding. There's a thing that's called the faint young sun paradox, where they're not entirely sure how life on Earth got started because the sun would have been much, much weaker back then relative to how strong it is here now. But Venus would have had the conditions maybe, I don't know, 1 billion years ago that we have now. And that's a very interesting idea. That's all it is, an interesting idea. I like to put it out there. Eventually they'll have more information. I just sort of have to leave you hanging on that account. They don't know more yet. But soon. So these are the 2 missions to Venus, dedicated missions. There have been a bunch of space probes that use Venus for gravity assist and just sort of snap Polaroids as they went by. The Venus Express from the European Space Administration and the Akatsuki from Japan have both visited Venus. Let's see if I have the dates for these. I want to say the Venus Express arrived in 2006. Do I have that right? And deorbited in 2014. And Akatsuki made it to Venus in 2010, went behind Venus, lost radio contact as planned, could not reconnect and just missed it. So they had to wait for it to go all the way around the sun, caught Venus again, did a corrective burn, and entered orbit. And Akatsuki is still there doing science. I'll read this to you. This is the article that made me think I should talk to SoVerA about Venus. NASA has long neglected, from 2017, has long neglected the world often described as Earth's wayward sister. The space agency hasn't selected a mission to explore Venus since 1983, when it began developing what would become the Magellan probe that was tasked with making a global radar map of the cloud-shrouded world. But since Magellan burned up in the Venusian atmosphere in 1994, NASA has had no presence of Venus, even while sending probe after probe from Mars. The lack of spacecraft and new data has starved the Venus community of many of its scientists. And this cuts to the heart of it for me. It's a popularity contest. People go where the action is, and that's just as true in science as it is in Hollywood. You will always have people who just have their thing and care a whole lot and won't budge. But mostly people follow the money because everybody needs to eat. But at last, in 2021, they promised me, 2 missions, one of which is another radar mapper that has better tools than Magellan had, and the other one is an atmospheric probe and orbiter combo. And the probe, as you see there in the concept art, if it works correctly, it'll do exactly what you see there and gather data all the way from the top to the bottom of the atmosphere. And if it doesn't work correctly, then it'll just explode on the way down, because that's a popular option. Da Vinci is the probe. Remember how I said they all have V's in them? The Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging. At one point, this was called Da Vinci Plus. Da Vinci was the original pitch name. It didn't make it. And then they added more stuff to it. It was Da Vinci Plus. They got approved with Da Vinci Plus, and then they renamed it Da Vinci. Nothing can be easy. Launch target 2029, fingers crossed. Veritas, they didn't have any more concept art for Veritas. It's a radar mapper. This is what they think you might see on Venus if you could, stand there without dying. One of these, I think it's this one, is the one that Suzanne Smirkar ended up getting them to bankroll. And I'm really happy for her. She was a very nice person who gave me an hour of her time that I spent on a rotary phone recording with a tape-based answering machine that I had fixed for the rubber band, so we just sound like old tiny cartoon characters when I play it back. And she gave me a whole bunch of very nice pointers that were basically, we would like to know so much more about everything. We would like better radar maps. We would like to know about the plate tectonics, atmospheric composition. The phosphine hadn't been detected yet, but I'm going to go out on a limb and guess she's interested in that too, because everyone else is. Meanwhile, and elsewhere, these are proposed launch dates for future Venus missions. Venus is popular. I did not think I would ever get to say that. Finally happened. The Indian Space Administration is sending something that I believe is just called the Venus Orbiter mission. And that gets there as soon as they're saying it might. Then it and Akatsuki will be there at the same time, and we will have a continuous coverage record that goes back to 2015, which would be very nice. We have something similar to Mars that goes back to 2004 with the rovers, and I think longer than the orbiters. A private space company called Rocket Lab is teamed up with MIT to send something that, as far as I know, doesn't have an official name, but I read one article that referred to it as the Venus Life Finder. Sure, knock yourself out. I'm happy for them. I hope it works, but in the back of my head, I'm also secretly resentful, because didn't we already say the billionaires could have Mars? Why can't we just have one planet just for science? 2026, voice. I could not find an explanation of what voice stands for. I'm going to guess I know what the V stands for. Chinese orbiter, currently a proposal, has not been approved. Might happen, might not. Then Da Vinci and Veritas. And then we get to the Venera D. So the article from 2017 that I read that excerpt from before, Venera D was already a proposal back then. Venera D, I think, was proposed in 2003. The Russian space program is in shambles, and they will not admit this even to themselves, but they have never managed to recover to the glory levels of the Soviet Union. And now the war in Ukraine has, among many other problems it's caused, jeopardized the relationship Russia's space agency has with the West. So Venera D is probably not going to happen. Or if it does, it just, happen. It's like fusion. Like they always say fusion's 20 years away. Venera D is always 20 years away. And then Envision, which I believe is from, I think that's the ESA, Envision. So we'll have all these craft that go to Venus all at once. To do a lot of things. Atmospheric analysis. Believe it or not, we don't know if Venus has lightning. We haven't been able to find any yet. This photo, by the way, is an ultraviolet photo taken by Akatsuki. You see how much higher resolution it is than the cameras from the 1970s? Why couldn't we have done this sooner? I'm indignant. Radar maps, same idea, better tools. Geological history. Did Venus have plate tectonics once? Maybe. We can gather information that will tell us more. The mystery of Venusian snow, a better understanding of current volcanism, the hunt for light, and finally lots and lots of nice photos. I think every spacecraft that's going anywhere near anything should have a camera on it. I will not be dissuaded on this. And finally, my closing point is this page from, I believe in French, it's called Le Fin du Monde. It's by Camille Flammarion, whose name I'm sure I just pronounced wrong, a French astronomer and novelist from the early 20th century, who wrote this book where he imagined the death of the Earth after an extreme length of time. Once upon a time, the idea was that the sun would just burn out and go dead. This was before we understood fusion. In practice, the sun will burn out, but before it gets that there, it will puff up and eat the inner planets. It will eat Mercury, it will eat Venus. They're still not sure if it'll get big enough to drag the Earth down. On the way there, Earth will turn into Venus. The heat will get so high up that life will eventually be unable to survive, or if it does survive, it will survive that same tenuous existence high in the clouds. The water cycle will break down completely once it gets hot enough for water to dissociate. I think that's the word, if it's not, I'm sorry. And eventually, Earth will just be baked dry. And so to look at Venus, it's good to look at it to see what might have been there in the past, but to look there now is also to understand Earth in the future, at least to some extent. And do I have anything after that? I did not. I can't remember. Did I manage to mute this or not? Because if not, now is a perfect time for everyone who is, oh God, I've been talking for an hour. If anybody's still here, you're welcome to ask me any questions you would like about Venus or space in general, and I'll do my level best to answer them. If you're talking, I can't hear me. Am I doing? Is there something that needs to be changed? We're gonna just have like a boot camp where all of us who do this like learn how to use.
Margot, turn off the share screen.
Oh, I'm getting there. Okay, great.
It's still muted.
We are not muted, but.
I think I just turned it on in the sound bar if you're talking about the laptop sound. Okay, if anybody has a question, please. From the audience. Hot dang.
I don't know if they'll be able to hear me, but...
I can repeat it.
Okay, so a couple of things. One, I wish I had remembered to look to see if I still have it, but when I was in college in 1980, there was a proposed Venus mission that was started with a V, pronounced VOIR, V-O-I-R, the Venus Orbiting Imaging Radar. I think I still have a button, a promotional button. Isn't it cute that in the 1980s, NASA thought they could get congressional funding if they distributed campaign buttons with their missions? So I have a campaign button for the VOIR. I wish I'd remembered to look for it.
Oh yeah, I could have shown it to the camera. He says he has a campaign budget from a mission called VOIR, VOIR, that never came to be.
Yeah, it never came to be, but the planning for it got folded into Magellan, which then did do the radar mapping. The question that I have heard many people use Venus as an example of what could happen to Earth with runaway greenhouse effect. My understanding is that's not the case, that it's the proximity of Venus to the sun is a big part of why it's so hot, and that Earth could never get that hot just with global warming. Is that your understanding as well? Or?
Let me repeat the question and then I'll give you my best answer. He's said, and I have heard this too, so it is going around, that Venus is being held up as an example of what could happen if global warming gets completely out of control in the future. And he said he didn't think that that was actually possible, that the proximity to the sun and the level of solar radiation is so much higher there that it's like an apples and oranges thing. And that is actually my understanding too. The Earth has definitely been hotter at times, not always, but at times in the past than it is now, and it never ran away like that. When they talk about Venus, they call it a runaway feedback because all the feedback loops collapsed and kept pushing it higher. When all the water turns into water vapor is actually a greenhouse gas. It makes things worse. Something I read somewhere in passing is that the amount of carbon that's made up in the atmosphere of Venus is what you would get if you took all the carbon on Earth that's in the biosphere and in coal and locked up in carbonates and burned it and released it all at once. So I guess I can't say that it's impossible, but there's nothing like that in Earth's history, and as real a problem as climate change is, Earth literally turning into Venus is probably not in the cards. Thank you.
Thank you.
Any other questions? Looking at all the little squares here.
Yeah, I just want to make a comment. Venus, I do a lot of planetary imaging for Alpha. And Venus is one of my favorite planets to image. And, you know, other than the phase, it looks very vanilla if you, just use a, luminance UV-IR cut filter. But if you have a ultraviolet filter, you can actually see the cloud tops on Venus. You can't see them visually. You have to, use a ZWO camera and process it and, auto stacker and registacks, but they show up beautifully. And I have, if you go to the 2023 Alpo conference, which is online, I gave about a 20-minute presentation on how to go about imaging specific. John Silason was there, so he can attest to it. And I go step by step how to capture and process the images in ultraviolet and in infrared for Venus. And it's really stunning. There's so much detail you can see in the ultraviolet that people aren't aware of. So.
That's cool. I didn't know you could do that from the surface.
Oh yeah. Right from here with an 8-inch Macassegrain, a larger, and ZWO camera. Your standard planetary imaging. Auto stackered and fire capture or sharp cap to get the video, and then auto stackered and registacks to align and stack it. But you can see a lot of detail. I don't have it on this computer, but I can show you another time some images I've taken. And
that'd be a good thing to send around to the SoVerA mailing list, because that sounds.
Okay. All right, I'll do that so you can check it out. Oh, there's a mailing list?
Yes.
Oh, okay. I wasn't aware of that. I don't think I'm on it.
Oh, well, I guess if you're not aware of it, you're probably not on it. That's the
Yeah. Okay. Patrick, put me on it, okay?
Patty says put him on it, Greg Shanos.
Or Margot. Yeah, put me on it. All right. Thank you.
Thank you. Anyone else?
All right, well, I'm not going to drag this out. I thank you all very much for coming. I hope you'll think of Venus each time you see it in the morning or evening sky. There's a whole lot going on there, and you'd never guess it from that point of light. But every world is unique, and thank you for coming. All right, I cede the floor to whatever comes next.
Pat, I was going to say something about the mailing list, if that works.
Yeah, go for it.
Okay. Actually, Greg, since you bring it up, anybody who might be interested who isn't currently on our mailing lists, this is an opt-in system. I think we discussed years back that like automatically putting you on it was bad for a variety of reasons. So that is also on our website where you can opt in and sign up for the traditional email lists. We also have a Slack server thing. I don't know if server is the right word. We have a Slack. Which is where I am trying to push a lot of our communications with mixed success. But if you would like a link to that, you can also email anybody on the board or me directly, and all of that contact information is also at SoVerA.org.
Okay. Yeah, that's the best one. That goes out to a larger percentage of people.
Some of the references to other things not limited to the chat. Let's start at the beginning. I think it's a very good place to start.
That's not Mary Poppins, that's Sound of Music. It's the Sound of Music.
Okay. So, for those of you that are local, somewhat, while we don't do much formal observing during the winter, every once in a while we will get a break in the weather where it's bearable temperature-wise, and they're going to be short notice, as was the last one, but we actually had a good turnout for that, and I think we advertised it 24 hours ahead of time, and we were able to get the word out. So keep an eye on the chat, the Slack channel, pretty much everything we use to get the word out. And you know, we may pull off some last minute observing sessions